today's lesson, I'm going to start off by just remember we just went over a few things about while loops. When it came down to while loops, this is the last example that we did, printing even numbers. We talked about last week that there were two ways that we could have done this, actually multiple ways that we could have done this, but I'm just going to focus on this one and then also maybe talk about, or we are going to talk about the other one as soon as I review this. There are four aspects to while loops that we discussed. The first one, or like I guess the four different components. So let's talk about each particular component. Let's see, we were on, let's see, the four components right here. We had the counter initialization first, the condition, the body, and the incrementer or decrementer. So the counter initialization was important to us because it allowed us to keep track of the number of repetitions. So how many times the loop repeated before it, so we just kept track, we're just counting it. The condition determines if the loop should run again or not, or so is the loop going to continuously run, or do we know when we have a stopping point? There's the body, which is the action. What do you want the code to continuously repeat? And then we also have the incrementer and the decrementer so that your code isn't stagnant. We actually do need to count or have some value that allows you to reach the stopping condition eventually. So that was like the four major components that we were focused on. The last example that we did was printing even numbers from 2 to 100. So because we start off with v is equal to 2, because that's the first number that is being printed, we also decided that we could increment by 2. So we taking steps with intervals of 2. So we have 2, 4, 6, 8, and we just kept going. The thing that we wanted to do was continuously print these numbers, so that was our action. And finally, we had our condition. So while v is less than or equal to 100, because 100 was the very last number that we wanted to print. And ultimately, with all of this, we were able to get a final set of code. And we were able to get our final set of code that looks something like this. So today I'm using something called, I'm not using my normal IDE today. I'm just trying something a little bit different. That way I could run it on my iPad so I don't have to constantly move back and forth. But you can see here that when we print out even numbers, we have the same conditions that I had on that PowerPoint. So we had a starting value, and a condition, the action, and we're incrementing by 2. When we typed out that code and ran it, this was our output below. So that's where we left off. Now today we are going to continue that PowerPoint and move on to the next one, or the other way that we could have potentially done this. So instead of a starting value starting value will still probably be 2 actually, if you think about it, but we could technically start different places. Let's say instead, just to challenge you guys, I wanted to do a starting value of v is equal to 1 as opposed to v is equal to 2. And instead of incrementing by 2 each time, because obviously that won't work, if we start at 1, if we increment by 2, that'll be 3, 5, 7, 8, 3, 5, 7, 9, 11. It'll just be odd numbers. So we can't increment by 2. Instead, we are going to increment by 1. That means if we increment by 1, we're going to be printing out 1, 2, 3, 4, 5. In the case our action was the same as the previous slide, which was just printing out the value. And we can't do that because our goal isn't to print out all numbers, it's to print out even numbers. So 2, 4, 6, 8, and you keep going. So instead of our old action, because if you start off at v is equal to 1, and then if you increase by 1, you'll have v is equal to 2, then v is equal to 3, then v is equal to 4, and you keep going. What should we have or implement so that we can print numbers that we only want to print, specifically the even numbers? What is a thing that we do or that we can use, that we always try to use in the case, like, you want to do one thing if something is true, to print another thing, or like do something else in the case something else. Oh, that could work actually. 1 through 50, print the counter value times 2 instead of just the value. Yes, we can do that. So we can do, so there were a couple of ideas. I actually kind of want to implement both of them. So the first idea that was brought up, let me make a little bit more space. Oopsies. So the first thing right here, so someone brought up a suggestion that we could just do print v times 2. That will inevitably give us only even numbers. But for the ending condition, instead of the ending condition being up to 100, we can do while v is less than or equal to 50. This could work. So let's do this one, and then we'll come back, and then we'll do the other one with if-else statements. 1 second. I'm actually not going to use this because I'm having issues with the server. So I'm going to switch over to resorting to this actually. Can everyone see the screen? Perfect. So this interesting suggestion, which I actually didn't think about, this wouldn't have been the first thing I would have tried to apply. So printing even numbers 2 through 100, and then I guess we'll call this part 2. And the starting value that was suggested was v is equal to 1. And then the ending condition that was suggested was v is less than or equal to 50. Actually, we'll just, instead of saying ending condition, we'll just call it condition. Oops. V is equal to 1. And then in terms of the action was to print out v times 2 instead of printing out v itself, which will give us like 1, 2, 3, 4, 5. And finally, we want to increment by 1. So let's go ahead and implement this. Remember, we have our starting condition. So this will be v is equal to 1. This is our starting value, not starting condition. Then we have our condition, our while loop. So while v is less than or equal to 50, so this is our condition. And then the action is to print out v times 2. Instead of just printing out v, actually actions/body, I guess. And finally, the incrementation is to add 1 to v each time. So if I run this, you can see that the things that have run 2, 4, 6, 8, 10, 12, and it just continues all the way to the very bottom. You can see it stops at 100. So this is a little bit different from what we did before. If you take a look, compare what we have here compared to what we did before, we went all the way up to 100, but we were incrementing by values of 2. This one takes the approach of starting from 1 and going up to 50, but doubling that amount each time, which will give you the same result, but a different strategy. Any questions? Okay, then I'm going to go back to the PowerPoint and we're going to try a different method, which someone suggested using if and else statements. So that's exactly what we're going to do next. So if you want to use if and else statements as opposed to using the, if you want to use if else statements instead. So this is strategy number 2. What could the condition be for an if statement? What do we want to do if something is true? What do we want? What are we looking for, I guess, in this case? So if v modulus 2 is equal to 0, right? So like we want to see if it is an even number, because if it's an even number, so remember modulus just means the remainder. So right here we have our remainder. So if we divide it by 2 and we get a remainder of 0, that means it's even. So if it's even, what do we want to do here? Perfect. We want to print out that specific number. We're going to print out v. What if it's odd? What do we want to do if it's odd? So let's say it's not equal to 0. The remainder is not equal to 0. What do we do? But like what action do we need to take in the case that it is a odd number? So what would we have to, do we have to hard code anything in for an odd case? So hopefully you guys are thinking no, because you only want to print out even numbers. In the case that it does come out to be odd, you don't want to do anything because there's nothing for you to have to do because you only need the even numbers. So let's go ahead and then printing even numbers 2 through 100. This is part 3. And then for this one, we're going to do a walkthrough as well. I didn't do a walkthrough for the last one because I want to do the walkthrough of this one, and then we have a time restriction. So I just rather quickly do this and then do a walkthrough and then move on to the next question. So printing out even numbers 2 through 100, when we talk about our starting value, still the same. It's when v is equal to 1. And when we talk about our ending condition, or I guess just our condition, this is while v is less than or equal to what this time. So we're incrementing in values, we're incrementing by values of 1 each time. That's already something that was given. So we'll talk about action. And then we also have to talk about incrementation, which is increment by 1. So what would our ending condition be? When do we want to stop? When we hit what number? Perfect. When we hit 100, we're going to stop for this time. It's kind of similar to what we had above, but above the very first one that we did right here, instead of incrementing it by 2, however, we were incrementing, instead of incrementing by 1 like we are in the current one, we're incrementing by 2 here. So this one had a different action than the one that we're about to code right here. So we decided if v modulus 2 is equal to 0, then you want to print out the value. Else, we decided you do nothing. So if you're not doing anything, that just means don't need an else statement. It's repetitive, it will take up space, so don't even bother having an else statement in the case you don't need to do anything. So we are going to code this out now. Let's do our starting value. So v is equal to 1 is our starting value. So we have starting. We have our condition. So while v is less than or equal to 100. And then we have our action. Our action is going to be multiple lines this time. So if v modulus 2 is 0, which pretty much means if the number is even, then we're going to print the v value. And in the case it is not divisible by 2, We don't do anything, so we don't need an else statement. All that's left for us to do is to increment by 1, so v plus equals 1. And we're done. This is the incrementation. And if I run it, we get the same exact answer as the previous two that we've done. A little bit more code, but it works still. So let's talk about the process that just occurred right here. Let's see. So our code started off with v is equal to 1. And then we had the condition while v is less than or equal to 100. And we had within that an if statement. If v modulus 2 is equal to 0, then we want to print v. Otherwise, we do nothing. And no matter what, we always incremented v by 1. So let's go ahead and quickly run through this. We'll start with v is equal to 1, because that was our starting point that was assigned right here. So we have v is equal to 1. When we go to the next step, we're doing this sequentially, you see that while loop. So while v is less than or equals to 100. So you want to check that it works. So is 1 less than or equal to 100? Answer is yes. So it is. So because it is, we are going to go into this right here, which is the body of the while loop, which is not showing up as me boxing it because there's something wrong with my connection. Maybe if I bring this over, it'll work. If it doesn't, I'll just have to reconnect and maybe it'll fix itself on its own. Doesn't look like it is, so give me 1 second to try this again. There we go. So we're gonna fall into that body so that we could run that code block because the condition 1 is less than or equal to 100 is true. So we see the next thing is this if statement. If v modulus 2 is equal to 0. So our current v value is 1. So is 1 modulus 2 equal to 0? Chat box is missing. Gotta pull that up. So is this a true statement? Right, it's false. So this is false. Because it's false, we ignore this thing that I am boxing in red. We are going to ignore that. Is anyone colorblind here? You know what, I'm not going to use this red. I shouldn't be using red anyways. Oh, wow. Okay. I'll switch up the colors soon. So we don't want to use this code block right here, because this statement was false. So that means we skip it and we go straight into v plus equals 1. So that means you increment v. Now your v value is 2. So now that you've finished this code block right here, you're going to go back here and then verify, is v less than or equal to 100? Our current v value is 2, so we're going to do 2 less than or equal to 100. Just for the sake of consistency today. Is this a true statement? Yes. Yes, it is. 2 is less than or equal to 100. This is a true statement, which means we're going to fall into the code block right here. And the first thing in the code block is this conditional statement. If v modulus 2 is equal 0, we know that our current v value is 2. So if 2 modulus 2 equal 0, is this a true statement? It's true. So because this is true statement, we are going to fall into the secondary code block, which is to print v. And our current v is 2. So 2 will print. Then after that, it's completed everything in that inner code block. And then it'll just go back to here. This one is going to be run regardless if our statement is true or false. So v plus equals 1 is going to increment our v value. So now we have v is equal to 3. Now we have reached the bottom. We're going to go back to the top and check this. V is less than or equal to 100 and see if that is true or not. So v is 3, so it's 3 less than or equal to 100. Is that true or is this false? True, very good. So this is a true statement. And that means we are going to fall into the code block here and run this. So if 3 modulus 2 equal 0, is this true or false? Perfect. This is false. So we are going to ignore this code block and we're going to go straight into this v plus equals 1, which means we increment our v value and now we have v is equal to 4. And then what's going to happen is because you have reached the bottom, you're going to go back up here, check this. So you're going to check if 4 is less than or equal to 100, which it is. So we're going to fall into this inner block right here. We're going to execute it. The first thing you see is if v modulus 2 is equal to 0, and that will give you this kind of code. If 4 modulus 2 is equal to 0, which this is also a true statement because this is even, which means even further, you're going to print out the v value. So print 4. So 4 will print, and then you're going to keep going with this process. We're going to skip on over to like around here-ish. So let's say now I'm at v is equal to 99. So we'll say that 90, so 2, 4, 6, 8, like we've printed a certain amount. Now we are at 98 and v has just become 99. So we're going to double check right here. Oops, I just erased stuff. So we're going to check right here. So while v is less than or equal to 100, so just checking is 99 less than or equal to 100, and you guys should say that it is a true statement. So you're going to fall into this code block right here and check if 99 modulus 2 is equal to 0. And that one is a false statement. So we don't print anything because it's false, but we will increment our v value. So v is equal to 100 now. Then we go back to the top and we check this condition, v less than or equal to 100. V is currently 100, so we have 100 less than or equal to 100. And this is a true statement, right? 100 is equal to 100, so we are going to go inside of the code block that the while loop is supposed to execute. Then after that, we are going to see that very first line, which is if 100 modulus 2 is equal to 0, and this is a true statement, right? 100 is an even number, so it will fall inside of this block, which will print 100. So 100 will print, and then it is going to increment v because now it sees this right here, and v will become 101. Now that we have finished the code block down here, we're going to go back up and double check if v is less than or equal to 100 because that is our condition for our while loop. And now we check 101 less than or equal to 100. This is a false statement, so we're done with our loop. Everything that is printed right here in this block, which is going to literally be just even numbers 2 through 100, is all we're going to see. So there were a lot of numbers, that were run, that were tested. 1, 3, 5, 7, all the odd numbers were tested as well, just to see if they're even or not. And because they were not even, they failed our condition of v modulus 2 is equal to 0. That means it does not print. Okay, let's go ahead and move on into the next code that we wanted to test. So we finished this one, and the next one is asking for input 10 times. So this one is going to be a little bit trickier. So if we were to rewrite this task at hand, instead of asking for input 10 times, maybe you want to say, ask user for input until you have done it 10 times. So that tips you off that you need to count. So when you first start your code, you have printed it, you have asked 0 times, which indicates that your starting value of the number of times asked is 0. Another thing that you could think about is probably like the increment or the decrement. You ask once, like once time each time. So it's like once, 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 once. So that indicates that your incrementation could be adding 1 each time. And in terms of the ending condition, you want to keep asking until you have asked 10 times. So that just means that you're going to keep asking while it's less than 10. And the action that you're doing each time is just asking, or like the action is just asking. But notice that in this code right here, or like if you look at this, the sample output that I have, we're doing more than just asking. This is going to be a little bit challenging. You have a input. You're going to ask them for an input, but also you will be printing out that very same input. So there's going to be more things in the body than what meets the eye. Let's go ahead and try this. So action will just actually list out in the code that I'm about to write out with you. So let's go ahead to sharing this again. So for this one, asking user for input 10 times. We had a starting value, which was number of times asked is 0, because that makes sense. When you start your code, when you run it, you've asked 0 times and it'll increase. It'll gradually increase. The condition is while asked is less than 10. So if you think about the number of times that it's asked like once, so 0 times, and then it'll run and it'll become 1. So by the time you get to 10, we want to stop. So some of you guys might get a little confused between why not do less than or equal to 10. If you do less than or equal to 10, then you'll ask the 10th time and get an input, but because you have an equal sign, it'll ask 1 more time, and then you'll unfortunately ask 11 times as opposed to asking 10 times. So we can actually test this out very soon. So we asked 0 times. So we start with asking 0 times. Then we want to keep going until we ask 10 times. And then here is our body, what we want to do. So the action that we want to do, actually, maybe I'll just call it action just to stay consistent. So first thing you want to do, ask the user for any input. I just spelled action wrong. And the other thing you want to do on top of asking the user for the input is return or like print out what you received. Okay. And finally, we have the incrementation. So incrementation or decrementation, but in this case, we're incrementing because we're counting the number of times that they have put in input. So this is going to be +1 each time. So the asked number of times asked will increase by 1, and that's what we should expect. Of course, this would do this. I don't know why it does this to me. So let's go ahead and try this out, starting with our starting condition or a starting value, which is asked is equal to 0. So we've asked 0 times. Then after that, we are going to implement, so starting, our condition. So now it is our condition, which is while asked is less than 10. There is more than one way that you could have written this. In fact, you didn't even have to start at 0. You could have started at 10 and then counted down to 0 if you wanted to. But in this case, this is just like, I think the most intuitive way. So we could do it like, we're gonna do it like this. If we have time, we can go back and try it different ways. But for the sake of time, I'm just gonna show it one way. If you're interested more, I encourage you to try other ways to implement this. So while asked is less than 10, so your condition, while you have asked less than 10 times, you want to implement your action. So what you are doing. So you're going to ask the user for any input. So remember how to get input? It was, so user input is equal to, you use the function input, and then you prompt them with what you want. So give me an input. And that will save the user's input inside of the variable user input. And then the second thing we wanted to do as an action is print out this user input. So print out what the user has typed in. So we can print out, you inputted, and then print out what they actually input. So the thing that will print out after they press enter will be you inputted, and then whatever they had typed in. So you'll see both of them. And finally, our incrementation. Our incrementation here is that just +1. So the number of times that they asked. So asked plus equals 1. We increment once, or we increment +1. So let's go ahead and try this out. So it says, give me an input. And I will say ABC. And it says you inputted ABC. Give me an input, 1, 2, 3. And you inputted 1, 2, 3. Let's say, give me an input, and I type in wow. I'm just gonna mash my keyboard now. I should have done, oh. So let's see how many times it did it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times exactly. Now, I kind of want to challenge you guys with this. I want you guys to think about, what can I put here so that instead of printing give me an input, give me an input, give me an input, it'll also print out the number, it'll also label how many times I've asked so far. So the first time it says give me an input, it should say 1, give me an input. The second time it says give me an input, it should say 2, give me an input. Then after that, I should say 3, give me an input, 4, give me an input, 5, give me an input. What can I add right here? So something specifically that will go in this space that will print out, that will label, I guess, the number of times I've asked so far. Any ideas? So let's try asked. Oopsies. Let's try asked. If I try it with asked, oopsies. My bad. I'm gonna have to probably write it like this. So it says 0 actually, which isn't what I wanted. Oops, let me stop this. So it says 0. I wanted to start with 1. Yes, we were looking for asked plus 1. Oops, plus 1. So let's try this. So notice that says 1, give me an input. So if I say ABC this time and enter, next time it'll say 2. So 1, 2, 3, and next time it'll say 3. So what happened here is that, remember, your asked value, we start at 0. So maybe I'm actually just gonna write this out. I'm gonna annotate this. So let's go ahead. I'm gonna maybe take a screenshot this time. That way, yeah, I'll take a screenshot of this time, just to make it a little bit easier when it comes to annotation for me. But the ordering for this is going to be a little bit more important. So it's just, give me 1 second to bring this over and then share this screen. There we go. All right, everyone can see this? Perfect. All right. So this is the code that we had just written out. And we start with asked is equal to 0. This is our starting point. Then after that, we go into our while loop. So while asked is less than 0. So because this is less than 0, or sorry, less than 10, my bad. Because it's less than 10, we are going to go into this part, that code block. We see user input, and this is equal to this part right here. I'm looking at this part, which is string of asked plus 1. So if you look at asked plus 1, asked is equal to 0. So that means asked plus 1 would be 1. So 1 will print and then give me an input. However, notice that for this asked plus 1 here, I never assign it a value. It's not like I did asked is equal to asked plus 1. This is not what I did. So all it does is add 1 to it. I get the number 1, and then it throws that value away after it's printed it out. So it doesn't permanently make asked equal to 1. It just adds 1 to asked and then throws away the value after it's been printed, because I don't have this equal sign in there. No assignment has been done. So just a side note, that's not how it works here. So this asked right here, this asked plus is plus equal to 1, that does have an assignment. That one has an equal sign. So it will add 1 to asked and update it. So there's a difference between this. So this is just equal to 1, and then it prints out the 1 here. And then after that, it prints out like you inputted this number, and then asked plus equals 1, so it prints input after. And then after that, it sees the asked plus equals 1. So now asked has been updated to 1. So now that it's updated to 1, I'm going to check this part right here again, because I've reached the bottom, and then I have to loop back to the top to see if it's a true or false statement. If it's true, then I fall into the code block. And because asked is equal to 1, which is less than 10, it will fall in and it will see this again. Asked plus 1 is 2 this time because we have added 1 to asked, but we're not updating it. So asked is still equal to 1, but we've just added 1 to it, gotten a temporary value that we use to print, and then we don't do anything else with it. So what we'll print here is 2, give me an input. And then it keeps going and going and going. So the number of times that this runs actually, so just in case some of you guys might be confused why I use less than 10 and not less than or equal to 10, is that if you think about how many times this should run, so we start with 0, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, which is the number of, like, this is how many, this is like these are the values that asked will become as it's printing. So if we actually count the number of times it will run, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This will actually run 10 times because you're doing 0 through 9 inclusive. So this is if you do it less than 10. However, if you start with 0 and you decide to end at 10 because you decide to put less than or equal to 10, you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then this will run 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times. So you'll get 11 user inputs as opposed to 10. So be careful that you are indeed running this or running whatever you need to the correct number of times. So this will keep going until you get to asked is equal to 9. And then you see that it's less than 10. So when you do asked plus equals 1, this will give you the number 10. And, or sorry, not plus equals. If you just do asked plus 1, it'll give you the number 10. So it'll print out 10, give me an input, blah, 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 blah. And then it'll print out the input. Then it'll increment asked. After it increments asked, then it will mean asked is equal to 10, which is not less than 10. So you're done. So you'll run this 10 times, and that's the perfect number of times we wanted it to run. And finally, so I don't think I'll be able to get to one of the, so we have this one, continuously asking the user for a numerical input until they input a multiple of 10. So we have this one, and we also have this one right here, which is Fizzbuzz. I think I'm going to have you guys try Fizzbuzz on your own. Oh, you could technically have starting value be 1. Yes. So sorry, someone, I just want to go ahead and just go back. What you could have also done, someone brought this up, is instead of starting at 0, you could have also started at 1. So you could have done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would also work. That would, you could do that. But there's actually a lot of ways that you could have done this. You could have also started at 10 and then brought your way down to 1. You could have started at 9 and brought your way down to 0. But just for the sake of beginners, I think 0 through 9 will work. But 1 through 10 works perfectly fine as well. And then, all right. So as for Fizzbuzz, I'm going to have you guys do this on your own as kind of like a programming assignment. there's a whole bunch of ways that you could implement this. So I want to go over Fizzbuzz quickly, and then we'll go back to this one, which we'll do together today. So write a program that prints out numbers 1 to 100. If it's a multiple of 3, you print out Fizz. If it's a multiple of 5, you print out Buzz. But for numbers that are multiples of 3 and 5, you'll print out Fizzbuzz. So if you look right here, this is a example of what you will see. So you see numbers like number 1, not a multiple of 3 or 5, so it prints out 1, 2, and then 3. 3 is divisible by 3, so you print out Fizz, but it's not divisible by 5, so you just write Fizz. 4 is divisible by neither 3 or 5, so you print 4. Buzz, which is 5, so this was technically supposed to be 3, this is technically supposed to be 5, but 5 is divisible by 5, so you'd print out Buzz as opposed to Fizz. And then you just keep going. Let's say you have 13 now. 13 is neither divisible by 3 or 5, so you just print out 13, and then 14, and then 15 is divisible by 3, and it's divisible by 5. So you print out Fizzbuzz instead of 15. And then you print out 16 and 17 and 18, and you just keep going. Or sorry, 16, 17, Buzz, or sorry, 16, 17, Fizz, 19, Buzz, Fizz, 22, 23. It's gonna be like that. So this is a pretty popular question. I know, like for like a couple of my students have had interviews, like internship interviews, where they just literally ask this question. So it's a popular one. And you guys could potentially know how to do it already. All right, so going back to this one's going to be a little bit more challenging. It's continuously asking the user for a numerical input until they put a multiple of 10. So a lot of this kind of goes out the window in a way. Normally, when you had a while loop, we had a set number of things, a set number of times things were supposed to run, but this time it's not like that. It's not a set number of times things need to run. However, it's more like a condition for something to run. So instead of writing it out on here, I'm going to go ahead and go straight into my notebook. We're going to try coding it out, brainstorming things together. If we can't finish it today, we could try finishing it next week, but I'm hoping that we'll be able to finish it today. That way we can go straight into for loops next week. Okay, so the goal for this one. This one right here, I'm gonna stop running this. All right. So this one, we are continuously asking the user for a numerical input until they input a multiple of 10. So this one you're gonna have to think about a little bit more, because before we had something like a starting value. We always had something like an ending condition. We always had some kind of action, and then we had an incrementation or a decrementation. So pretty much an updater. The only thing that's very clear here is the ending condition. What is the ending condition here? When do we know when to stop the loop that we are trying to run? It doesn't have to be code. You could just tell me what it is. Right, so if the input, so you want to, actually not the ending condition, I guess, the condition, the running condition, I guess. What will keep it running is while the input is, or I guess we'll write it multiple ways. So stopping condition. You know when to stop when the input is a multiple of 10, which you can easily translate to stop, or sorry, not stop, keep running, continue to run while the input is not a multiple of 10. So talk about this again. We know to stop because according to the question, we want to ask the user for numerical input until they input a multiple of 10. So that means that we want to stop when the input is a multiple of 10, which means we continue to run while the input is not a multiple of 10. Because if it's not a multiple of 10, you want to keep running and running and running until you do get a multiple of 10, which is when you stop. Which means that I can translate my loop into something like this. While the input modulus 10 is not equal to 0. So while it's not a multiple of 10, while the input is not a multiple of 10, you keep running and running and running. Is everyone okay with this so far? So this one was a little bit more difficult to decipher because it wasn't something that was very specific, like a starting point and an ending point. This is up to the user and the user's intelligence at this point. So keep going. So this is a stopping condition, which gives us our running condition eventually. The other one that might be more, or might be easier to find is the action. What is the action that is being done here? What do we want to continuously do, I guess? Yes, we want to continuously ask for input. And let's just make things a little bit fun, I guess. Let's also add that we want to tell the user if it's a multiple of 10 or not. If it's a multiple of 10, we'll just say not a multiple of 10, and then we'll just loop again and continue to ask. If we do get a multiple of 10, we'll say, hey, you got a multiple of 10, and then we'll move on. So this will give us a little bit more to do. Do we need an updater? So do we need to increment or decrement at this point? Right, we don't need one. Not really, okay? So technically, because our condition is based on the inputs, our input is our updater. So we don't need a separate updater yet. We'll see. We'll see how this goes. So we just don't need a separate updater. So let's go ahead. The only thing we're missing right now is a starting value. Let's do the starting value later. So let's say input is equal to question mark right now. I don't want this to be, oh, this is perfect. So we'll leave it this empty for now. We'll put a question mark. Let's go with our while loop. So while our input modulus 10 is not equal to 0. Look how that looks. So input modulus 10 is not equal to 0. This is our condition that we were able to derive with a little bit of extra thinking. And we want to continuously check, or after we continuously check, if it's not equal to 0, so meaning that it is not multiple of 10, we want to ask for a new input. So input is going to be equal to, since we're going to be taking modulus, we want to see if something is divisible by 10. We're going to convert it into an integer. So it's not just a string, because remember, if you do input, it's going to be a string. So int input, give me a number. On top of that, our action, we want to check if it's a multiple of 10 or not. So what do I need here? Oh, you're right. Normally user input. Thank you. What do we want to do here if we want to do the second part of the action? Tell user if input is a multiple of 10 or not. What do I need? Perfect. So if the user's input modulus 10 is equal to 0, we can print that this is a multiple of 10. Otherwise, so else, we want to print out that it is not a multiple of 10. Which brings us to this. What do we want our user input to start off as? Normally we had a set starting point, but this case now, oops, that should be user input. So don't name it input. Someone brought this to my attention. Do not name it input. Input is the name of a function that is reserved in Python. So don't name your variable input. So I've named it user input instead. But what can we start user input as? We know that we have to activate this loop somehow. That's like a key thing. So what should I use user input as? There's more than one answer to this. One would be the better answer. Because your user input, you could use 1, you could also use 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9. Don't use 10, because 10, if you use something that you could plug into here, and then it'll give you a remainder of 0, then your while loop won't run. It will never run. So, but if you use something that will not give you a remainder of 0, then your while loop will be activated. It'll run. So for example, right here, I started off my user input as 1. So right here, it's starting to run. It's asking me, give me a number. If I say 4, it says not a multiple of 10, and it'll prompt me again, give me another number. So I'll say 9. It's not a multiple of 10. If I do 13, not a multiple of 10. However, if I do 20, it says multiple of 10, and notice it's not asking me again for another number. If I decide to use, let's say 10 here, and try to run it, it's already finished running and it's never asked me, because if I use 10 and I do it right here, 10 modulus 10 is 0. The case is while the modulus or while the remainder is not equal to 0. So the remainder is 0, 0 not equal to 0 is false. So it'll never go in this while loop if your initial value, your starting value, is something that will make this false immediately. So that's the reason why I decided to make this one right here 1. But you can make it any number that would make it false the first time at least. So here it's working again. So starting value was any number that would make the running condition false. And that is it. Remember, I do want you guys to try Fizzbuzz on your own. That will be like it's your programming assignment. And as for next week, we will jump straight into for loops. We'll do a quick review of while loops, like literally like maybe 3 minutes of a review, then we'll jump straight into for loops.